Okay, so I want to talk about counting leap years. To do this, I'm going to start with the idea of counting multiples. And so I'm going to let the notation close brackets 1 to capital M indicate all of the integers that are bigger than or equal to 1 and are less than M, which it becomes a shorthand for just 1, 2, 3, etc., up through m minus 1. Okay, so I'm going to count all in these, I'm going to count all of multiples of a certain size. And so let's just say, consider the multiples of n in the interval 1 to m. Okay. Now, those are, to do that, notice that the biggest number in that set is m minus 1. So what I'm going to do, I'm going to take m minus 1 and apply the division algorithm to it. M minus 1 is equal to m minus 1 integer divided by n times n plus, okay, m minus 1 modulo n. Okay, right? So this is strictly less than n. And so this is, again, m minus 1 integer divided by n. All right, so I have that. So in that way, what I can do, I can say, start out counting with 1, 2, get up to 1 times n, 2 times n, 3 times n, 4, until I am finally up to m minus 1 integer divided by n times n, and then just till I'm done, and up until I get to m minus 1, and I'm done. And so from here to the end, there are going to be m minus 1 modulo n terms. Okay, I'm not a good writer. Modulo n terms. And that is strictly less than n. So what I've just shown is that the interval, okay, 1 minus 1 to m contains 1 up to not including m contains m minus 1 integer divided by n multiples of n. Okay, so take that, put it in your pocket. All right. And so what are we going to do with it? Well, what I'm interested in is counting leap years. Okay. And I want to count the leap years before the year y. So I'm going to pretend that we're going to start counting in the year 1, 2, 3, and count up to the year y minus 1. Okay. Because these are the leap years that occur before y. Okay. So that means we're doing this Gregorian. So first stage, am I divisible by 4? Well, there are y minus 1 integer divided by 4 years that are multiples of 4 in that interval. Okay. Then, okay, is it a turn of a century? So I have y divided by minus 1 divided by 100, multiples of 100 in that. And then, okay, well, is it divisible by 400? Well, I have y minus 1 integer divided by 400 of those. Now, here is the thing, okay. All of my multiples of 400 are multiples of 100. All of my multiples of 100 are multiples of 400. So, in counting the leap years, that occur before y, up from the year 1 up to y, this is going to give me, okay, y minus 1 integer divided by 4 minus y minus 1 integer divided by 100. Okay. If it's divisible by a 4, it's a leap year, unless it's at the turn of a century. Okay, then it's not a leap year, unless it is a multiple of 400, in which it is a leap year again. So you count only the multiples of 4, but you don't count them if they're multiples of 100, unless they're multiples of 400. So, gee whiz. Okay, but here is the formula. The leap years between the year 1 up to, but not including the year y.